This is the lesson for Chapter 2, Section 6, Perimeters and Areas of Similar Figures. And so I'm going to mainly be looking at perimeters, the ratio of perimeters, but we are also going to be finding ratio of areas. And so let's take a look at the first example problem here. And this is not going to be what you're going to see on the homework. Homework's going to be more like the ones down here. So this is just going over what the ratio of perimeters means. And so we're going to start with the ratio of corresponding sides. And so if I was to do that, if I'm told that these are similar figures, and they already say that right here, they find the ratio of the perimeters of similar rectangles. They tell us they're similar. So I'm using that tilde sign to show, okay, that tells me that they are similar. So the ratio of corresponding sides would be like this. 4 is to 6. So this number here, 4 and 6, correspond, and so those are corresponding sides, and that reduces down to 2 over 3 if I took out the common factor of 2. Well, looking at another set of corresponding sides, 8 and 12. You see, if I do 8 over 12, I take out the common factor of 4, and I end up with the same ratio, 2 to 3. Well, what we're going to find with ratio of perimeters is they are the same as the ratio of the corresponding sides. And so we're going to see that. So let's take a look at the ratio of perimeters. So before we can get to that, we have to find out what the perimeters are. Since we're dealing with the rectangle, this side's 8, this side's 4. So if I go ahead and add up all those numbers, the perimeter is going to end up being 12 times 2, which would be 24 in this case. And so I just did 4 plus 8 is 12, and then just doubled that for the other side. And then the next one would end up being 6 plus 12. So the perimeter here, we end up saying, in doubling 18 gives me 36 in this case. So if I take a look at those, the ratio of the perimeters, and so I look at, and again, I'm doing red to blue, so that's important. See how they have red first, blue second? So this means this number is on top of the fraction, and the blue is on the bottom of the fraction. And so that's why I have it set up. Now if they said blue to red, I would reverse this. I would take the reciprocal of this. So anyhow, I'll go ahead and write the ratio of the perimeters. 24 over 36. Now take out the common factor. This time 12 is the common factor, and when we do that, we see we have 2 over 3, the same exact number. So you see how they match. So when we're finding the ratio of perimeters, all we need is the ratio of the corresponding sides. Let's write that down. Ratio of corresponding sides equals the ratio of perimeters. And that's what you'll need to know for tonight's homework for those questions. Now, they're going to also ask about ratio of areas. So let's take a look at the ratio of the area and how that comes about. So if I look at the area of this, the area equals 4 times 8, which is 32. And the area of this shape is 6 times 12, which is 72. So if I look at the ratio of areas, again, red to blue, I would end up doing 32 is to 72. I go ahead and take a look at the common factor. Well, the number pops into my mind right away is 8, and that makes 4 over 9. And that's reduced, so I can't go any further. So let's compare. Let's compare the ratio of areas, to perimeters and see what we can find out here. So if we look at the areas, it's 4 to 9. If we look at the perimeters, it's 2 to 3. Well, what did they do? Well, I see if I just took 2 to 3 and I squared this, if I squared that, that would make 2 over 3 times 2 over 3, which would be 4 over 9, and that represents the area. So what we end up seeing is that the ratio of areas equals the square of the ratio of sides, or perimeters, because the perimeter is the ratio of the perimeters is the ratio of the sides. And so we're going to see that. And so that's a key component to what we're asking, what's asked of you in these problems. So the two figures are similar, so they tell us that, so we know that they are similar. So I'll put the tilde sign there for similar. Find the ratio of shaded to non-shaded, perimeters and areas. Okay, shaded. So remember, it said shaded to non-shaded. And so that's going to tell you how to set up your fraction. So we're going to start off with the perimeters of ratio of perimeters. Let's do that one. Ratio of, and let me go ahead and fix that part, of perimeters. So the ratio of the perimeters is just going to be shaded is 8, non-shaded is 3. That's it. That's the answer. So make sure you write down ratio of perimeters equals, and then you tell me which one it is. There's two of them. Now the ratio of areas, well, you have to square. We're taking 8/3 and we're squaring that. And so you don't just square the 8, you square both numbers. Because when I square it, it's 8/3 times 8/3. And when we go ahead and do that, I end up with 64/9. That would be that answer. Let's take a look at this next one here. Here it says we got the shaded figure and non-shaded figure. So if I want to find the ratio of perimeters, I'm going to do 6:10. Why did I do that? Because it's shaded to non-shaded. Then I go ahead and just take out the common factor to reduce the fraction, make it simpler, and that makes 3/5, and that's the answer I'm looking for. Well, then they say find the ratio of areas. The ratio of areas is just 3/5 squared. And so when I square that, I have 3/5 times 3/5. And that gives me 9/25. That would be the answer. So then let's take a look at another type of problem where we use that concept to solve. So here, they're giving us the ratio of perimeters is 4:7. Find the missing side. They want to know this side right here. So I'm going to write down 4:7. Now, how do I set up the next fraction? Well, if you look at it, 4 is the smaller number, and the larger number is 7, and that goes along with the size of the figure. So the smaller figure is 16, the larger figure is x. And so I've got it set up correctly now. Now all I have to do is cross multiply. So I do 4 times x equals 16 times 7. So we'll pull out that calculator, and I'll do 16 times by 7, and that gives me 112. So now I have 4x equals 112, and I divide by 4, and x equals, I take that number, divide it by 4, and we get the answer of 28. So 28 meters, because the 16 was in meters here. Now, as I'm doing these problems, instead of using a calculator, sometimes you can make the problem go a little faster if you just look at factors. You know you're multiplying these numbers, but you're also going to divide by 4. And I see 4 goes into 16. So what I could have done, instead of multiplying them, I could have just reduced 4 into 16 goes 4 times, and then multiply the 4 and the 7 to get 28 as well. So just another way, if you didn't have a calculator, that might help you out. Well, those are problems you're going to see on tonight's assignment. Good luck.